In this video, we're going to introduce ANSYS Mechanical and build the model. The first step is opening ANSYS Mechanical and creating the analysis. From the Start menu, open ANSYS Mechanical Workbench. See, I have version 18.0 already open, to enter the general workbench environment. Define the analysis system by expanding the standard analysis folder in the toolbox, if not already open. Drag the status structural analysis type object template onto the project schematic. The analysis system is displayed as a vertical array of cells, a schematic, where each cell represents a component of the analysis system. You address each cell by right-clicking on the cell and choosing the editing option. At this point, you may give the analysis a name. Call it Case 1. Change the units to US Engineering by clicking the Units tab. Make sure the Display Values in Project Units is clicked and click US Engineering. Next step is to define the needed engineering data. For this analysis, we need to define a new material. Right-click on the engineering data cell, choose Edit to open the Engineering Data tab. Add a new material under the Outline Schematic window by giving it a name. We're going to call it Plate Material. Depending on your initial settings, certain windows may or may not be displayed by default. You can turn on or off certain windows under the View menu. Add isotropic material property to your new material by dragging it from the toolbox onto your material, or double-clicking. Under the Properties window, define Young's modulus to be 10,000 KSI, or since these units are in PSI, we're going to do 10 million PSI, or 1 to the 7th PSI. And Poisson's ratio, we're going to define as 0.3. Okay, now we've created our material. We're going to save the project. This is something we do often to make sure that in case something happens, something crashes, that we have our project saved regularly. So we're going to go to File, Save As, FE Project. You can name it whatever you like, as long as you remember what you call it. So now our project is saved. The next step is we're going to create the geometry. So click over from the Engineering Data tab to the Project tab. We're running the analysis in 2D, so we need to specify this before creating any geometry. This is essential. It will create it in 3D if you don't specify it beforehand. Ensure that the Properties toolbar is open. Click on Geometry and change Analysis Type to 2D. Remember that windows can be turned on or off. If it's not displayed, you can right-click on Geometry and hit Properties. That will display this window as well. Now we're going to open up the Space Claim component by right-clicking on Geometry and clicking New Space Claim Geometry. It will take a few seconds to load. Now we are in the Space Claim application. Close this directory. First, we need to make sure that the units are US rather than the standard SI units that it defaults to. So click File, Space Claim Options, click Units, change type to Imperial. This is what we're going to want to use. Now click OK. From the Orient toolbar on the top left, we're going to select the arrow next to the View selector, which is this blue cube, and then select Front. This will give us a head-on view and the XY axis that we want. On the bottom of the drawing window, select New Sketch Plane. It's a pencil with the graph. And click anywhere in the window to create this XY sketch plane. For this model, we need to create one surface, which is the square plate with a quarter circle punched out of it. We're going to begin by making sure that the snap to grid option is on. That'll be helpful. Create the sketch from the project definition of the plate by using the rectangle command. Rectangle command is right here. You can click R instead of going up there and clicking that. Now click in the origin of this axis, drag it over to the right and up. For the width, we're going to input 10 inches, click enter. Height, we're going to click 10 inches and enter. Now click the escape button and escape once again to get out of the sketching. An important thing to know about panning in the sketching window is to hold Control and the center mouse button and pan over to put this into the center of our window to get a better view of it. Now the next step is to create the cutout by using the circle command. Circle command is up here. You can also use C. Now click the origin and we're drag up, and we're going to set the diameter to be 2 inches. Click enter, then click escape and escape again. Now in the mode toolbar, which is up here, we're going to select 3D mode. This 3D mode is going to create solid objects for us. And now what we're going to want to do is delete these circles. Make sure that the select is highlighted, and back in the sketch window, select both parts of the circle, holding down Control to select both parts. Right click and click delete. There we go. Now we have the geometry we are looking for. It's useful to name the sketches of their corresponding parts. We're going to go right click in here, hit rename, and we're going to rename this plate. So this is useful if you have multiple parts. That way you can keep track of them in the future. So some general notes on the dimensions of the plate: the height of the plate, 10 inches, width of the plate, 10 inches, radius of the hole, 1 inch. Okay, save the space claim design file. We can name it plate, just in case in future analyses we have this geometry already created, we can import it. Save that and close space claim. Return to the ANSYS workbench and save the file once again. Save the project. Our next step is to define the part behavior. Back in the ANSYS workbench, we're going to right click the model cell. Select Edit option to open the ANSYS mechanical component of our system. Your created surface should appear on the main graphic window once it loads. It's attaching our geometry file. There we go. Under geometry, we can see that the plate that we named is in there. Our first step is to make sure that the US customary units with inches are used by clicking on the Units tab and making sure that US customary, the inches one, is used. Next, we're going to look at this plate, expand the geometry under the outline. Under the Geometry tab, select that and make sure that 2D behavior is set to plane stress because we're doing a plane stress analysis. Now select the plate under the project window and make sure that stiffness behavior is set to flexible. We're going to set the thickness to 1 inch. Make sure the material assignment is not the default structural steel, but it is the plate material that we defined earlier. Now ensure that nonlinear effects are set to no, because we're doing a linear elastic analysis. So we don't want any nonlinearities. Our next step is to apply our loads, supports, and boundary conditions. We're ready to define boundary conditions. It doesn't matter which order we do this in. For the plate, we need to define our load, which is a pressure of 1 KSI along the top edge. So we right-click on Static Structural, click Insert, click Pressure. Click the Line Selection tool. Make sure Edge Selection is highlighted. Select the top edge and hit Apply under Geometry. Now our top edge is selected. Now set Define By to Components. Make sure the X component is set to 0 and the Y component is set to 1 KSI, or in this case 1000 PSI. Click Enter and confirm that the pressure is applied in the correct direction, which is tensile. Now we need to constrain the left side of the plate so it is completely free to move in the Y direction, but completely constrained from any movement in the X direction. By adding this boundary condition, we establish the symmetry of the simulation without directly defining to ANSYS that the plate contains a symmetric edge. Right-click on Static Structural, click Insert, and click Displacement. Make sure the line selection, edge selection is highlighted. Select the left edge and click Apply next to Geometry. Make sure that this edge is highlighted. We're going to define it by components. Make sure the X component is set to 0 because we do not want it to move during the analysis, and that the Y component is free to move in the Y direction. In a similar manner to the previous step, we're going to constrain the bottom edge of the plate in the Y direction and making the X component free. So click Insert, click Displacement, make sure that edge is highlighted, highlight the bottom edge, click Apply on Geometry, make sure that the X component is set to free and that the Y component is set to 0. Now look at the static structural branch and make sure that we have our constraints, which is our loads and our boundary conditions applied. Make sure to save the file. In the next video, we're going to create the mesh, run the analysis, and generate the results.